Welcome to qnawire.
Okay, we're told the rate of a chemical reaction is equal to, actually, we're told it's proportional to, which is why I'm going to include this little k. We can mostly ignore it, and I'll explain why. That the rate is proportional to the concentration of A squared, and that it's inversely proportional to the concentration of B. So this equation represents what our rate is at any given time. Okay. And the k is just some constant. It really doesn't matter because what we're going to do is compare rates. And so when we set up an equality between those rates, the k will cancel. Okay. So what they're getting at is they're saying if we have some rate, right, and we know what our a is and we know what our b is, suppose that we changed b by 100%. We increased it by 100%, right? So we're going to change b, increasing it by 100%, which, if you weren't aware, is the same as doubling it. So I'm going to put 2b here. And they want to know, what do we have to do to a? I'm going to put a y. That's like what we have to do to a to keep things the same as they were before we doubled b, right? So this is what things look like before we doubled b. This is what things will look like after we double b and after we change a, so that our rate overall doesn't change, right? So now I'm going to do some simplification with this equality. I don't really care about this side of the equation anymore. That's just, explaining that this is what our rate was and setting up the equation. Okay, the first thing I'm going to do is I'm going to cancel. I'll change pen color so it's a little. I'm going to cancel the k's, right? The k's don't matter. We've got them on both sides of the equation. The other thing I'm going to do is I'm going to factor out my 2 and my y, just so it's a little less confusing looking. Okay, so I'm going to say this is still a squared, and this is still b. But on the right-hand side now, I'm going to say I've got y squared times a, and I've got 2 times b. And the thing is, basically what we're doing is we're going to solve for y and then figure out what that means in terms of changing a by some percent, right? For example, if y turns out to be 2, we know that's the same as increasing b by 100%. If y ends up being 0.5, we know that's decreasing a by 50%, and so forth. Okay, so let's continue. Now we've got to do, sorry, I forgot to put the square there. Okay, so now we can start canceling things, right? Like this b cancels with, I'll change color. Pens again. The b cancels with the b. A squared cancels with a squared, right? And we're left with 1 on the left-hand side. 1 equals y squared all over 2. And we could move the 2 to the other side, multiply both sides by 2. Right, so we get 2 equals y squared, and then we'll take the square root of both sides to solve for y. Root 2 equals y. And what is the square root of 2? It's like 1.4 or something. I gotta look it up real quick. I never remember. 1.414. So 1.414 equals y. All right. So now let's look back at this y times a. This is what I think, we can figure out what this means in terms of percent. Like, so before we had just a, and then we did something, and now all of a sudden we've got 1.414 times a, right? You could even say that this is 1a, right? We started with 1a, and then we did something, and we've got 1.414 times a. Okay. So what that looks like to me is that we added 0.414a. Does that make sense? That how we got from the left to the right was that we added 0.414a. And since we're dealing with fractions here. This 0.414 is the same as adding 41.4%, right? This is a fraction, this is a percent. All we've done is multiply by 100. So what I'm saying is to go from having however much A we had before to having 1.414 times that much A, what we've done is we've added 41%. We've increased the concentration of A by 40%, roughly. So the answer is 40% increase, which is option D.